Now, in this video, we are going to look at finding the general solution of a differential equation that looks like this: x plus 3 brackets dy by dx is equal minus 2y is equal to x plus 3 brackets power 3. Now, when we evaluate this differential equation, we realize that it is a linear differential equation. So what do you do with a linear? So why would we say that it is a linear? It's a linear because we must look at this form. So linear differential equation must satisfy the form dy by dx plus py is equal to q. Yeah, so if you look at the above differential equation keenly, we can make it to be of that form. So how? We begin by dividing throughout with x plus 3. So we divide throughout x plus 3. So we shall have x plus 3 out of x plus 3 dy by dx minus 2y out of x plus 3 is equal to x plus 3 power 3 out of x plus 3. Now this goes with that, we cross them. So, and one of these will go with this, will remain with the 2. So if we continue, we shall have our dy by dx minus 2y out of x plus 3 is equal to x plus 3 squared. Yeah, now the next thing is to get the integrating factor. So how do we get the integrating factor? So the integrating factor is actually exponential integral of p dx. But what is our p? Our p is actually negative 2 out of x plus 3. Yeah, so we go ahead and get the integrating factor. So the integrating factor will be an exponential, the integral of negative 2 out of x plus 3 dx. Now this one tells us that our integrating factor can be the exponential of negative 2 ln of x plus 3. Yeah, so this negative 2 can go up. So when it goes up, going back, so we can have our integrating factor as exponential ln of x plus 3 power negative 2. So according to the laws of logarithms, this eventually becomes our integrating factor equal to x plus 3 power negative 2. So because a ln is a log base e, so exponential to power log base e of anything, we get the argument. So that's why it ends up like that. Now the next thing is to multiply it throughout. Where are we multiplying the integrating factor? We are multiplying the integrating factor here throughout. So when you multiply it throughout, we shall have it's actually, this one is actually, our integrating factor is actually 1 out of x plus 3 squared. So we multiply it throughout. So when we multiply it throughout, we shall have 1 out of x plus 3 squared dy by dx minus 2y out of let us go back and we see it clearly. It is there 2y, so you are multiplying out 2y so times this is going to be x plus 3 then power 3 is equal to x plus 3 power 2 then over x plus 3 power 2. So this will cancel with that. Now if you keenly see this has gone back to what we call exact DE. We can retrace where it came from. So retracing where it came from a derivative of y out of x plus 3 everything squared then with respect to x, so will equal to 1. So after knowing that, if you haven't watched my video about the exact DE, please you can go and watch it. I'm also going to link it in the description. So we go ahead and integrate. So we shall apply the integral on both sides. So we have it as y out of x plus 3 squared is equal to x plus c. Now we can go ahead and get our y. So I'm getting our y. So our y eventually is equal to x plus 3 squared into x plus c. And this is where this is the general solution of our differential equation. Thank you for watching. And then please like the video if you have understood. Like the video, share because sharing is caring, and please don't forget subscribe. If you haven't subscribed, we meet in the next. It means a lot to me. We meet in the next. Thank you.